Are you guys able to see my screen share here?
Yes.
Okay, sounds good. So before we get started, any questions from last class? Did you guys get a chance to go through the recording in case something was not clear? I'll just ask, Ashi, how did you feel? You're on mute.
Yes, so I watched a little bit because I was a little confused with some of the derivations, but I think I got it now.
Okay, but after watching the recording, you're good now. Okay, cool.
Yeah.
Arnav, I'm not able to see your full face. Can you turn your monitor a little bit? Tilt your monitor. Yes, that's better. Similar with Rachit also, right? I'm not able. Okay, it's better definitely with Rachit. Saurabh and Neve, please turn on the videos. Akshaj, how was your experience? Did you have any doubts? Did you go through the recording?
Yeah, I got it.
Got most of it. Okay, Saurabh, are you there? Okay, he's disconnected, looks like, so he'll kind of join back. Okay, so let's continue. So last class, we focused mostly on triangles, all the different properties of triangles, and also the Pythagorean triplets, right? Pythagorean triplets, all of that. Okay, and then we did some bit of polygons. For example, we looked at the number of interior angles, exterior angles. What is the value of the interior angle, exterior angle? What is the number of diagonals in a polygon? We did go through the number of diagonals, right? If I recall, Neve, how many diagonals does an n-sided polygon have? Yeah, Neve.
I'm not sure.
Okay, which is good. If you're not sure, you should be able to derive it off the bat. Sana, can you help me? How many diagonals in an n-sided polygon?
N multiplied by n minus 3 upon 2.
Excellent. Can you explain how we got this expression, Sana?
So basically, n minus 3 refers to the 3 diagonals a specific side can't make with itself. As in a hexagon, inside A, you wouldn't be able to make diagonals with A itself or the two sides, for example, B and F.
Exactly. Only one small mistake in what you're saying, not sides, but vertices.
Sorry.
B and F are vertices, they're not sides, but yes, you're right. You cannot make a diagonal with A itself and B with B and with F. That's right. Continue, Sana. Therefore, n minus 3.
And when applied, so it's multiplied by the number of sides, but minus 3.
Yeah.
And this is applied for each vertex. That's why it's multiplied by n.
Perfect.
And because for A you can make a diagonal with E, but E you can make a diagonal with A as well, it's divided by 2.
Excellent. Very well explained. And therefore, the double counting deserves a division by 2. Does this make sense, Neve? Right? Why it's n into n minus. So each tells a story. N minus 3, she told a story. Times n, she told a story. Divide by 2 to she told a story. That's how we should connect. And in a way, it's good that you might forget, right? It will happen that you should forget. As in, you should forget, as in, you should have the confidence to be able to derive it anytime. If you know the basics, you can derive it, right? Sana, one honest question. Did you recall this like from memory, or did you have to actually look at your notes briefly while you're talking to me?
I looked at my notes, but after looking at it for a second, I was able to recall everything.
Excellent, excellent. Okay, sounds good. Rachit, can you tell me in a 30, 60, 90, what is the ratio of the side lengths? If I have P, Q, and R, what is the ratio of the side lengths in a 30, 60, 90 triangle?
It's I forgot. I looked at the notes, but I still forgot.
Okay, Arnav.
So I'm confused. I think it's a 1:1:√2 if I'm not wrong.
Okay, if it's 1:1:√2, then won't it be isosceles? But 30, 60, 90 is not isosceles, right?
Well, so sorry. It's 1:√3:2, I think.
Exactly. So if this is one part, this is √3. Arnav, do you know approximately what √3 is numerically?
No, no.
Okay. Neve, do you know approximately what root 3 is?
1.7.
Excellent. Yes, it's 1.7. So values like root 2, root 3, you should know approximately. Root 2 is 1.4, root 3 is approximately 1.7, which is why it's in between 1 and 2. So it's the medium side, right? The smallest is 1, the medium one is root 3, which is 1.7 approximately, and the largest one is 2. Okay, and back to in a 45, 45, 90, although Arnav already called out the answer, even though for the wrong one. Ashi, can you remind me again, what is the ratio of the side lengths in a 45, 45, 90? You're on mute. You're on mute. You're on mute. I can see still you're muted.
Yeah,
Yes.
sir. Sorry, I think it was. So 30, 60, 90, haven't you written 1, 2, and root 3?
Yeah. Yeah, I want for a 45, 45, 90 now.
Oh. So 1, 1, root 2?
1, 1, root 2. Yeah, again, you're referring notes, right? Okay, but that's fine. But you remember how we get this 1 and root 2, Ashi?
Yeah, because
How
you
do we
added them.
how do we get that?
So 1 square and 1 square, and then that's
Correct.
root 2,
Square
which
root of
is
2.
root 2. Yeah.
Correct. And it's 1 and 1 because it's isosceles. Okay. Let's see. Saurabh, what is the ratio of an internal angle to the external angle of a regular octagon? Okay. So all of you do it, but Saurabh will be the one calling out the answer on this one. What is the ratio of the internal angle to an external angle of a regular octagon? Or actually, I'll break it down. You tell me what is the internal angle of a regular octagon. Just tell me the numerator of this. What is the internal angle of a regular octagon? How do you work it out, Saurabh?
So you do n minus 2, n minus 2 into 180
Very good.
to find the amount of sides.
To find
So
the
in octagon it is 8. So to find the sum of the interior angle.
excellent. Yes.
So in octagon there are 8 sides. So you do 8 minus 2, which will give you 6 into 180.
Yeah.
Which will give you 1080.
Yes. You don't have to actually do it because I'm going to divide it by what now to find the each. I want ratio of each internal. Divide by
n divided by
n.
n.
Divide by n, in this case 8. So all I'm saying is
So eight.
don't multiply by big numbers unless it's needed. So yes, even though you're able to multiply 180 times 6 easily, try to be lazy in multiplication and division, right? So that you can wait for cancellations. So this becomes 3 and 4. This becomes 45. And therefore I can keep the last multiplication very easy. So it's 135 degrees, right? Each internal angle.
Yeah.
Does it make sense? Okay. Akshat, you're also with me. Snigdha, can you turn on your video? Okay, next question for Snigdha. Are you ready, Snigdha?
Yes, sir.
Okay. Let's see. Okay, so find how many sides. So you have to find n, right? An n-sided polygon. An n-sided polygon, I'm saying the ratio of the internal angle to the external angle. Internal angle to external angle is 11. Find the number of sides of this polygon. Is the question clear? I've just written it cryptically.
Yes, sir. Wait, it's a regular polygon?
Very good question. Regular polygon. Only then I can talk about ratio, right? Otherwise, each interior angle and each exterior angle, let's say, will have a different value, then I cannot talk about ratio. Yes. Thanks for spotting that. In an n-sided regular polygon, the ratio of the interior angle to exterior angle is 11. Find the number of sides.
Yes, 1 second.
All of you do it, but Sigda will call out the answer on this.
2 minutes.
Sure. No, not 2 minutes, but maybe 45 seconds.
Yes, sir. Uh, Is it 24 sides?
24 sides. Okay. Does anyone else agree with her or disagree with her? Sana, do you agree or disagree with her, or have you done it yet fully?
Still solving.
Still solving. Ashi, how about you? Do you agree or disagree with her?
Found out. So I missed the sums. I'm doing it.
Okay, all right. Anyone else? Okay, let's check. If we do 360, what's the total of all the exterior angles? It's 360. Therefore, each becomes 360 divided by 24, which is 12 goes 2 times, 12 goes 3 times. So 30 divided by 2, which is 15 degrees. Which means if each exterior angle is 15 degrees, each interior angle is 15 degrees, each exterior angle therefore is 180 minus 15, which is 165, which is indeed 15 times 11, and therefore she is right. Does it make sense? Well done, Snigdha. So how do you approach it? So let's say each internal angle, let's call it I, right? And each external angle is E. Then we have 11. So we have I equal to 11E, right? So let's say the polygon is tilting something like this. You don't know how many sides it will be, but if this is E, the exterior angle, this is I, which is 11 times E, which means 12E is this 180 degrees. And therefore, E is 180 by 12, which is 15 degrees. And therefore, she concluded by saying if each exterior angle is 15, she backworked this. So this is 360 by N, and therefore N is 24. I'm assuming that's how you did it, Snigdha. Is that what you did?
I did it slightly differently.
Okay, go ahead, please.
So I thought that the total total value of exterior angle will be 360 degrees.
Yeah.
So the total value of interior angle will be 360 into 11.
Yeah.
Uh,
So this is the sum of interior. So she basically said the sum of interior and sum of exterior should also have the same ratio of 11:1. Continue.
So after that, I got the number 3960 as a sum of interior angles. And then I applied the 180 into n minus 2 formula.
Excellent, excellent. Only one small correction I would say. So this is essentially 180 times n minus 2. And this we know is always 360 degree. So while solving 360 times 11 equal to 180 times n minus 2, again, the same message as I was giving someone before this, right? Saurabh,
It's
right?
long.
Like try to cancel off and make best use of cancellations. Why should I deal with 3,960 and all that? I don't want to waste my brain cells for unnecessary thing, right? So 22 equal to n minus 2, therefore n equal to 24. Well done. Makes sense? Neve, makes sense to you as well, right? All good?
Yes, sir.
Okay. What else did we cover? Pythagorean triplets and remembering perfect squares and perfect cubes and all that, right? So I'm going to call out a number. You should tell me it's something power something or this, that, right? So what does this number mean to you? Type of question, right? So let's see. 961. Akshaj, what does 961 mean to you?
961. It will be 29 square.
29 square. Do you agree, Sana?
Yeah.
She agrees. Okay. No, it is wrong. Ashi, your hand is up.
1 square.
That is- Okay, sorry. Multiple people answered. Ashi, you said 31 square as well? You
Yes.
corrected it. And then Akshaj, you corrected it to be 31 square as well, I guess. Is that what you did, Akshaj?
Yeah.
Okay. All right. Next question. 2. Let's see. Rachit, what does 343 mean to you?
7 cube.
7 cube. Excellent. Very fast. Nice. Okay. Saurabh, what does 729 mean to you? You don't have to raise your hands. I'll make sure everyone gets a chance. Don't worry. What does 729 mean to you? Saurabh.
7.
You don't have to raise your hands, guys. Okay. So it's okay. So yeah, go ahead, Saurabh. Okay, I'll pass. Arnav.
Sir is 27 square.
27 square. Very good. Anything else? Neve, does 729 mean anything else to you?
Sir, it's
90.
Not Arnav, not Arnav. Neve.
Not sure, sir. I can't remember.
Okay. Gyan, are you back online? I know you're running a bit late. Are you back online to turn your video on? Okay, you are. So what does, we are just doing pattern recognition, number recognition. What does 729 mean to Gyan?
I think 9 cube.
9 cube. Yes. Anything else? Snigdha.
So can I answer?
Snigdha. What is 729? Anything else other than 27 square and 9 cubed? You don't have to search too far. In the same family as 27 and 9, you can just explore.
So 3 to the power 6.
Correct.
Sorry, 9.
No, you're right. 3 power 6. So it's 9 is 3 power 2. When you do 3 power 2 whole power 3, it becomes 3 power 2 into 3, which is 3 power 6 indeed, not 3 power 9. Yeah, you're okay? Okay. Jan, why is your video off? Turn on your video, please. Rachit. X, Y, Z, right, is a 3-digit perfect square. Okay, so I should write X, Y, Z as like this. 3-digit perfect square. I'll say 3-digit perfect square. Perfect square. Okay. And ZYX is also a 3-digit perfect square. Can you tell one possibility for X, Y, and Z?
No, sir.
Okay. Sure. Jan, you want to try?
Sir, maybe 169 and 961.
Excellent. 169 and 961. And what's more interesting is even 196 in this, even X, Z, Y is also a perfect square. So let's say this is X, this is Y, and this is Z, right? For 169. Then this is ZYX, which is reversed. Also 196 is also a perfect square, right? It's 14 square. Anything else? Anything else? I'm just asking for 2, XYZ and ZYX. Doesn't have to be the XZY. That's 169 is a little special. Yeah, Ashi, go ahead.
So 144 and 441.
Excellent. 144 and 441. Akshaj, 441 is which square?
21.
Okay. And 144, Sana, is?
12 square.
Okay. All right. Arnav, next question. You ready?
yes, sir.
In total, okay, so I have a set. I have a set, let's say A, B, C, D, and all that. Okay. Okay. Where this is a set of all perfect squares and all perfect cubes. Okay. So I'll just say set of all perfect squares and cubes, perfect cubes less than or equal to 1000. Okay. In fact, I should say 0. I should say what the starting value is also, right? So let me just create more space here. Okay. So set of all perfect squares. So 0 less than or equal to this number, less than or equal to 1000. Okay. So 0 is a perfect square. It's also a perfect cube. Okay. Find the number of elements in this set. All of you do it. Arnav will answer this. Number of elements in this set. Okay. So one obvious question would come. If a number is both a perfect square and perfect cube, how many times should it get counted? Neve, if a number gets, for example, 64 is both a perfect square and a perfect cube, you should count it once or you should count it twice? Neve.
Once.
Once. Because in a set, it's the unique elements that counts. Okay.
I think
All right.
that's the answer.
Okay. You have only one attempt, Arnav. You cannot say, oh, made a silly mistake. I'll give you 30 seconds more.
No,
Be sure of your answer,
yeah,
and then
I think I'm good.
you're super confident of your answer. Okay, go ahead. What's your answer?
32.
32. Okay, fine. Let's wait to hear from others whether they agree or disagree. 30 seconds more, and someone can agree or disagree. Arnav, you cannot open your mouth now. That's it. You
I have a question.
yes, Sana.
So the numbers in the set have to be a perfect square as well as a perfect cube?
No. A set of all perfect squares. Okay, I said good point. Or perfect cubes. If that's the case, they'll be very, very small, right? Which are both perfect squares and perfect cubes. But yes, that's also a fair question. But in this case, either perfect squares or perfect cubes.
Okay.
Or, but good question, Sarah. Yeah, she's paying attention to the word or versus and. Very detail oriented. Okay, all right. 30 seconds more.
Sir, I think it's more than 32.
Tell me what's your number?
Sir, I got somewhere around, I think 40.
What do you mean somewhere around 40? Are you saying 40 or are you saying some big band around 40? Tell me one number.
No, sir. So can I just get 2 seconds? I just need to recalculate it and I'll tell you.
Okay. 2 seconds is over, by the way, but yes, 15 seconds.
I
Yeah,
have
Sana, call out your answer.
38.
38. Okay, this is Sana. And this is Arnav here. Okay. Anyone else? I'm opening it up for anyone.
So 39.
39. Okay. All right. We have 3 answers, right? So this is Gyan. Let's discuss. Okay. And unless anyone wants me to hold for another 10 seconds, I can hold before discussing. Ashi, you're saying something?
One as well as are we counting one as both?
I already answered that question with an example 64.
Oh, okay. Yeah.
So what is your answer, Ashi?
38 only.
So you agree with?
Yeah.
Sana. Okay. All right. Let's discuss, right? So in terms of perfect squares, so perfect squares will start from 0 square because I'm including from 0. 0 square, 1 square, 2 square, all the way till 31 square, which is 961. So there are, how many numbers are there from 0 to 31, including both? 32 numbers already, right? Whenever I count how many numbers there are between starting A to ending B, including both, it's always B minus A plus 1, right? If you count from 0 to 2, there are 1, 2, 3 numbers, right? So 32 numbers already, right? Plus we have more. So clearly, Arnav, gone, which is why I said, take another 30 seconds, don't rush. Okay. All right. Now, perfect cubes, we have 0 cube, 1 cube, all the way till 10 cube. That is 11 numbers. Okay. 0 to 10, including both, is 11 numbers. But we have to subtract some excess, right? So there are 43, but the excess is how many? The numbers which are both perfect squares and perfect cubes, which means there are 4 of them, you're saying, Sana?
Yeah.
Okay, so let's see. Which means if something is both a perfect square and a perfect cube, it must be a 6th power. So 0 power 6 is 0, 1 power 6 is 1, 2 power 6, which is 64, which is why it's both a perfect square and a perfect cube, right? 3 power 6, which is 729. These 4 have to be ignored. And therefore, the answer is indeed is 39. Jan wins. Does it make sense, guys?
But
What is the mistake
um,
you made, Sana and Ashi?
I didn't consider 0.
Okay.
No, I
All right.
forgot.
You
Can you
forgot what?
explain it again? I didn't understand.
I'll explain again. No worry. Ashi, what did you say? You forgot what?
Got 0.
You also forgot 0. But you included 0 here and here, did you?
No, sir, I didn't count it there also. I forgot to count it anyway.
Okay. So in that case, your answer would have been 31 here. And then you would have counted 10 here. And then you would have subtracted 3. And therefore 38. Is that what you guys did?
Yeah, I did 32, then yes, sir, okay. I counted it open, I didn't count it teacher.
Yeah. In fact, I specifically, while saying this itself, I said 0 is both a perfect square and a perfect cube. Okay. Rachit, you wanted me to explain it again, or who was that? Who wanted explanation again?
No, I was just counting. I'm fine.
Okay, but someone wanted an explanation again. Who was that?
For me, sure.
Saurabh, was that you?
Yes, sir.
Okay,
Yes.
I'm not going to explain. I'm going to let Arnav explain this because he got it wrong. Punishment for Arnav is explain this to Saurabh. No, I'm just kidding. Explain. Go ahead, Arnav.
So first you have 32 perfect squares. So you have till 31, which is 961.
No, this is not this. Is this how I explained, Arnav? Thora dheere se and okay. Saurabh, did you understand what he said? No. Good. Okay. Try one more time, Arnav.
So your closest, like the perfect square under the last perfect square under 1000 is 961. So that is 31 square. So then you have to consider all numbers from 0 to 31, and 0 is also a perfect square because 0 into 0 equals to 0. So then you get 32 numbers.
Stop right there. Much better. Is this clear, Saurabh?
Yeah.
Why you get 32 perfect square? Okay.
Yeah.
Arnav, stop here. Akshaj, take over. So you explained the first row, Arnav. Akshaj, explain to him perfect cubes likewise.
So cube, the largest cube, which is either less than equal to 1000 is 1000. So that's 10 cube. And since it's including 0, so 0 cube is 0. So counting 0, the cubes will be 11. So
So that's 11. Okay, Snigdha, can you finish it off? Now we have 43. What is the subtraction by 4?
So some numbers are both perfect cubes and perfect squares, and these numbers are powers of 6.
Not powers of
So,
6, sixth powers.
Sorry, 6 powers.
Powers of 6 would mean 6 square, 6 cube.
Yeah.
Yeah. Okay.
These are the sixth powers. So the largest sixth power, which is below 1000, is 3 to the power 6. So we have to count 0 to the power 6, 1 to the power 6, 2 to the power 6, and 3 to the power 6. And thus 4 are both perfect squares and perfect cubes. So we have to subtract 4 from our number.
Exactly, because they are double counted. Okay, very well done, guys. As a team, you explained it well. Saurabh, you're okay
Yeah.
now? Does it
Yeah.
make sense?
Yeah.
Okay, and therefore you are with this. Okay, so next question. Let's see. Who was it? Rachit. Can I have a triangle with side lengths 10, 20, and 30?
No, sir.
Why not?
Because the two smaller sides have to be greater than the third side.
Be strictly greater than the third side. Okay, now I'm going to say there is a triangle ABC. Okay, ABC, whose perimeter, so this is the perimeter. The perimeter is 30. All sides are integers. All sides are integers. Okay, now I want you to tell how many non-congruent triangles are possible. I'll explain what I mean here. Non-congruent triangles possible. Okay. The reason I'm saying how many non-congruent triangles possible is I'll give one example and then you'll understand. Can AB be, let's say, 12, BC be 8, and CA, the third side, be 10? Is that a valid triangle, Neve? Okay, because 10 plus 8 is definitely more than 12. On the other hand, I could have AB is 8, this is 10, and this is 12. That's also possible. Let's say this is AB, this is BC, this is CA. These two triangles are congruent triangles. So this AB is different, but the AB there is the CA here, something. They're congruent triangles. So I'm saying count these as only one possibility. Does it make sense to everyone? Okay, Sana, are you with me? Okay, if I do this, how many such triangles will I get? Okay, this is one example where I've written, and I'm saying these two should be counted as one possibility. Another possibility would be, let's say one side is 14, another side is 7, another side is whatever, 9. Like this, there are multiple possibilities. Okay, all of you take 2 minutes and then we'll discuss. Question is clear to everyone, right? After 1.5 minutes, do not ask, can you repeat the question? If question is not clear, call out now.
I didn't really understand the question. Like,
Which part? Ashi, can you repeat the question for Sana?
Which part?
Yeah, which part did you not understand? That's what Ashi is asking you, Sana.
so for the non-congruent triangles, how exactly do you define them?
Like I said, so 12, 8, 10 is one triplet, which adds up to 30 being the perimeter, and it's a valid triangle.
Yeah.
14, 7, 9 is another one. Like
Yeah.
this, there are many more. How
Okay.
many in total?
So where the longest side, no.
Yeah, that rule we discussed, which is why I said 10, 20, 30 is it possible, and Rachit answered that's not possible. That's a known thing. You don't have to repeat. For a triangle, the largest side has to be smaller than the sum of the other two sides.
But 14, 7, 9 shouldn't work then.
It will work, no? 9 plus 7 is 16, which is more than 14, right?
Right, more. I thought it was less.
Okay. It has to be more, right? Only then we did the sticks example, right? Only then the sticks will otherwise collapse. Did we
Yeah.
not do this? Yeah. It has to be more.
Do this with a formula, or were we supposed to write down every combination?
You have to write down, but you can intelligently write it. You can systematically write it in a very clever way and quickly arrive at the answer. Even if you don't have an answer, if you want to share what your approach will be, even that is welcome.
May I share my approach? But
Yes, yes, Sana, go ahead.
So I began by halving 30.
Yeah.
Because then if the two sides are equal, it wouldn't work, and anything beyond that wouldn't work.
Very
So
good.
if one of the sides is 15, then automatically none of the triangles would be possible. So
Excellent. Very good. So 15 or above for the longest side will not work.
yeah.
Right? Is this clear to everyone? This is a very good starting point. In fact, this is the starting point, I would say. Extremely well done, Sana. Does it make sense? Or maybe all of you pretty much were starting in the same direction only. Right? You cannot have the longest side 15 or beyond, because the sum of the other two sides will be 15 or less in such a case. Therefore, 14 is the largest side possible. Continue, Sana.
Yeah, so 14 is the largest possible side. I began, so from that point, I've only gotten like combinations, as in 14, 1, and then 15. But I don't know how to move
Wait,
forward.
so if the longest side is 14, then for that combination alone, there'll be 8 combinations.
Yeah.
And
Actually, even just before that, if you have 14, Sana, you said 14, 1, and 15, but you're contradicting yourself. You're saying 14 is the longest side.
Oh, sorry.
Right? So you cannot have that. Okay, so this is Snigdha. You were saying with 14 being the longest, you have 8 combinations. What are those 8?
I think it will be 1 and 15.
1 and 15 is not possible, no? Because that means 15.
Oh yeah. Oops. Oh, then it will be 7 combinations.
Okay, what are those 7? Starting from 2 and 14, is it? The other 2?
Yeah, 2 and 14. 3 and
13.
13.
All the way till?
4, all the way till 8.
8 and 8. Okay, so one small change I would make in the approach is start to count them in decreasing order. So I'll say, right, you started with 14 is the longest side, right? So let's call this, so let's say oh, by the way, one small thing I should say, whenever you label sides and angles, the opposite letter should be the small letter, right? Opposite to capital A is the small letter A. I think I mentioned this last time, I'm not sure. Opposite to capital B is a small b. The side lengths are always small letters. Opposite to vertex capital C is the side small c. Okay, so I will say, I'm going to have my triangle such that C will be greater than or equal to B and B will be greater than or equal to A. That way I'll have some orderliness in it. So you all started off fine by saying 14 is the largest possible for C, right? Doesn't matter between A, B and C, whichever is largest, I can always say effectively it's the same triangle. That example I gave you, right? 12, 8, 10. I'm choosing to put 12 as the largest one, then 10, then 8. Does it make sense? Because all the rearrangement does not matter. Everyone with me so far? Any doubt? Okay, so now rather than count 1 and 14 or 2 and 14 rather, put 14 here and 2 here. So it's a non-increasing order, or rather almost decreasing order. I don't want to say decreasing, because 14 and 14 is not decreasing, right? It's still flat. So non-increasing is the word to use. So this is non-increasing order. As I'm going from C to A, non-increasing order. So 14, 14, 2, and then the logic is same, 14, 13, 3, all the way till this will be 14 anyway, I don't have to fill it, till these two become equal. And that becomes equal when these two add up to 16, which is 8 and 8. Okay, and then this collection, as Snigdha was saying, how many numbers there? 8 to 14. You're starting with 8 all the way till 14. You don't have to fill all these numbers in between, Ashi. As long as you have the pattern, that's good enough, right? That's what I'm saying. You can intelligently list it out. There are 7 numbers here. Do you agree, Ashi? Starting from 8. So the main difference is 8 to 14, including both the 7 numbers.
Yeah.
You're with me? Okay. Next, we move on to where the longest side is 13. Again, the same logic. If this is 13, then this cannot be more than 13 by our definition, right? We are considering in this sequence, right? So 13, 13, and what is the balance? It has to be like 4, right? 4. And then we can go all the way. So the sum has to be 17. So we can write one more just for example. This is decreasing by 1. This is increasing by 1. And ultimately, this is going to end when these two add up to 17, right? 13 plus 4 is 17. It's going to happen when 9, 8 combination is going to be reached, right? So how many numbers here? 9 to 13. You can easily count, right? There are 5 numbers here. And next, let's go for the next sequence where it starts with 12. This has to be 12. And then the balance is 6 here. Okay, and the next one would be 12, 11, 7, and so on, all the way till 9, 9. Correct? And
Yes.
that's all. And that's how many? 9 to 12, including both, is 4 numbers. And then very soon we should reach our destination, right? So the next one can be 11. If this is 11, this has to be 11. And the balance is, how much is this? 8, I guess. 11 plus 8 is 19, balance. And then 11, 10, and 9, and that's it, right? We cannot go further. And then the last one is, I know it's the last one because if the largest side itself is 10, then these two have to be just 10 each, in which case it's an equilateral triangle. So only one possibility here. And then you literally add all of these, right? Which is not very difficult. So 7 plus 5, 12, plus 4, 16, 18, 19 numbers. All right? So there are 19 triangles possible. This is clear. 19 triangles possible. Okay. I'm going to make another variant of. Are you guys able to see that I'm minimizing this so that I can see the full screen, or how is it for you? showing that you can see the full stretch, right now?
Yeah, yes, sir.
Okay,
If
cool.
you're minimized.
Right, as opposed to now it's much bigger, right? Okay,
Yes.
cool. Okay, now is this clear?
Should it actually be 18 because you said it's supposed to be non-congruent?
Non-congruent, yes.
So then shouldn't it be 18?
Why? Each of these 19 is a different triangle, right?
No, so I think he's saying that, I think he thinks that congruent is equilateral.
Sorry,
Oh, no, sorry. So I was getting confused with the number thing. My bad.
okay. No, but I do want to understand your question. Why did you say it's 18? Maybe someone else had the same doubt. So
No. So I got confused. Like for a second, I thought equilateral and congruent meant the same thing.
and who was it who spotted his confusion exactly? Was it Snigdha, you? You read his
Yes.
mind very clearly. How's that?
Sir, I guessed because congruent means equal, so he should get confused with equilateral.
Okay. So how many non-congruent, right? So non-congruent meaning, so here I said in between here somewhere in the 12 series, we had this 12, 10, and 8 here, right? So I said the ordering does not matter whether it's 12, 8, and 2, 12, 8, and 10, or 10, 8, and 12, all that. Okay, I'm counting all of those collection as one. Okay. Now, another a slight variant of this question. Okay, so you don't have to do it right now, but think and come back to me for next class. Suppose I don't consider 12, 8, 10 and 10, 12, 8 as two different triangles. Suppose I do consider them as two different triangles, as in I'm marking them as specific. This is specifically the side C. This is specifically the side B. This is specifically the side A. Then these two triangles have to be counted twice, correct? Understand what I'm saying?
Yes,
if we
sir.
do that, then the answer will be not 19, but more than 19, much more than 19. What will that answer be? That's something for you to think about and come back to me. Right? For example, I'll just give you one example. Right?
So it would be 114.
Very good, wrong answer. Why is it 90? Why is it 114? Tell me.
19 times 6, because like each triangle can be arranged in 3 ways.
Wonderful. Wonderful. I said very good, wrong answer. The very good was because of the multiplying by 6, because he said anything can be arranged in 6 ways, right? Any 3 numbers, like you can see that CBA, CAB, ABC, ACB, right? All that. But why is it wrong? Can someone tell me why it's wrong? Rachit, why is it not 19 times 6? I'll give it to Rachit and then pass it on to Sana. Yeah.
I don't actually know.
Okay, Sana, can you tell me?
Because 10, 10, 10 will not change.
Exactly. So 10, 10, 10 will still be 1. There's only one way of 10, 10, 10. Or 11, 11, 8, there'll be only 3 ways. Because 11, 11, 8, you're saying where does the 8 go? 8 goes to this side or that side or that side. There's only 3 ways. So not all numbers will get multiplied by 6. Some will get multiplied by 3, and some, like she said, will get multiplied by 1. In fact, this is the only case where it will get multiplied by 1, where all the numbers are 1. So in other words, all the scalene triangles, maybe we can just quickly do it here itself. All the scalene triangles, you're right, Akshat, will get multiplied by 6. All the isosceles triangles will get multiplied by 3. And all the equilateral triangles will get multiplied by 1. So it should be few. Oh, was it Arnab or was it Akshat who said 19 times 6? Akshat, you did, right? Okay, so it'll be less than 114 for sure, because some numbers are getting multiplied by 3 and 1 and not all by 6. Okay. In fact, can you guys work it out? Tell me what. It should not take too long. I'll give you another minute. So the answer should be between 19 and 114. What is that number?
Is it 97?
97 is what Snigdha says. Okay. Any other contenders with her? Agree, disagree? Jan, what are you getting?
Sure, I'm still calculating.
Okay.
100.
Yeah, go ahead, Akshay. What did you say?
100.
100. Okay. This is Akshaj. This is Snigdha. Okay. Arnav, any answer?
So 1 second. I think it's 99.
99. Okay. I like when there are a variety of answers. Okay, good. Arnav, anything else? Shall we discuss, or I'll give another 15 seconds for people to wrap up?
So I got 100. I got 103.
Excellent. Multiple answers. Okay. Anything else? I'm sure Sana will have a fifth one. Saurabh is giving me a dirty look. क्या हो रहा है इधर? क्या कुछ भी? Okay. Last 10 seconds.
I'm getting 79.
79. Okay. All right. It's good. There's a cluster of answers here. So she's boldly deviating from the majority. Okay. All right. Sounds good. Let's discuss. So we said there are 19 triangles in total, right? 90. I want to just minimize this because this is taking too much space. Okay. There are 19 triangles in total, we saw, right? So let's split the 19 into 3 parts: equilateral, isosceles, and scalene. Okay. Equilateral, we saw there's only one. We saw there's only one equilateral. How many isosceles? Let's start counting. So 14 in this 14 series, we have 14, 14, 2. All the way it'll be either it'll be the topmost one and or the bottommost one. 14, 8, 8. There are 2 of them. These are the isosceles ones. Okay. Then you're able to see my full screen, right? Where I'm pointing and all that. You can see the double screen right now. Sana, you're able to see my double screen, right?
Yes.
Okay, cool. I was not sure because I'm not sure what you guys are seeing. So 13 series, there's only one here. In the 12 series, I have 12, 12, 6 as well as 12, 9, 9. Right? That's 2. And then the 11 series, I have only 1. And that's it. Right? The last one is equilateral. So number of isosceles triangles is 2 plus 1, 3, 5, 6 of them. Equilateral is 1. So the balance should be the scalene. So how much is this? 19 minus 7, which is 12. So this gets multiplied by 6. This gets multiplied by 3. This gets multiplied by 1. There's only one equilateral triangle, right? There is 18 isosceles triangles, and there is 70 scalene triangles, right? So there's 91. I'm very happy none of you got it right, right? I don't know. I'm still not sure my answer is right because I could have done some silly mistake. If one of you finds any silly mistake, I'll be happy to take it. But does this make sense? I think. Does anyone find a mistake in what I did?
Shouldn't it be 92?
Why 92?
Oh, sorry, 90.
Yeah. And did you guys find your mistakes, respective mistakes? Sana, I'll start with you. What did you do to get 79?
I followed the same method. I think I just went wrong in the math.
Okay. As in, do you counted the number of isosceles and scalene triangles as different, is it?
Yeah, I think like while multiplying it by 6 and multiplying it by 3, I must have got mixed up between isosceles and scalene.
Okay. All right. Fine. Anyone else? Gyan, what was your mistake?
So I only took 4 isosceles triangles. I did not take 6.
Sorry, you did not what? Sorry.
I miscounted the isosceles triangles. I took only 4 instead of 6.
But I also saw only 4.
But then your answer would have been less than even mine in that case, right? Oh, you increase the number of scalene triangles and decrease the number of isosceles triangles, is it?
Yes, sir.
Okay. So if you guys, so Snigdha, you said you also did the same mistake. You said 1, 4, and then the balance, how much was this? 14 here, is it?
Yeah. So
So that's 14 times. So you said 1 plus 12 plus, that was your 97, Snigdha. Okay. But then even then, Gyan, you're not able to justify your answer. Snigdha justified her answer, but you're not justifying your 103 still.
So miscalculation in maths, miscalculation.
That's what, like, put everything in the kitchen sink, right? Like everything else has one mistake. All right. No, I'm just kidding, guys, but makes sense, right? How to approach this kind of problems systematically. We can count. Ashi, you're convinced that I don't have to list out all the possibilities, but I can still quickly count all of them.
Yes, sir. I started writing down everything again.
Yeah. Okay. Sounds good. So we are bordering on the permutation combination topic. Okay, but all of them, like I said, are related, right? So let's get back the focus on geometry a little bit. That's what we started off, right? Just a quick recap of stuff that you already know anyway. So if I have a set of parallel lines, and I have a transversal like this, okay, then there's 8 different angles that get created. So let's say I'll just label them 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now you'll have different pairs of angles that are either equal or they are supplementary. Okay. Again, all of this is known stuff, but just for completeness, I'm making sure that we are all okay on this. Okay. So the first class of numbers is vertically opposite angles. Vertically opposite. Rachit, can you give me a pair of vertically opposite angles here in this?
1 and 3.
1 and 3, right? So 1 and 3 are vertically opposite. So are 2 and 4. So are 5 and 7 and 6 and 8, right? So they are literally like an X formation. Okay, and the vertically opposite angles are what, Rachit? They are equal or supplementary? You're muted, Rachit.
So they are equal.
They are equal, right? Vertically opposite angles are equal. Yes, go ahead.
What's the name of this topic?
We are continuing on geometry only.
No, like this
specifically in geometry, like I wanted to start with quadrilaterals hierarchy, but as a precursor to that, I wanted to do parallel lines and transversals.
Okay.
Right? I mean, no specific topic as such, just knowing all of this is like basic stuff only. Vertically opposite angles. The next collection is corresponding angles. Corresponding angles. So Saurabh, can you tell me a pair of corresponding angles?
Yes, 3 and 6.
3 and 6. No, 3 and 6 are not corresponding. Corresponding means?
Oh, so 2 and 6, sorry.
Yeah, 2 and 6. There should be like a L shape, right? You have, so this guy and this guy are corresponding. And corresponding angles are equal or they're supplementary?
So they're equal.
They're equal. Okay, so 3, 7, 2, 6, 1, 5, 4, 8, right? All of these are corresponding. They are also equal. Okay. All right, Ashi, co-interior angles.
4, 5, 3, 6.
So sorry, say, please again. Start again.
So co-interior as an allied, right? So 4, 5.
4, 5. Yeah. 4, 5 and 3, 6. These are the only two pairs, right? They are co-interior, as in they are interior. So this is the interior between the two parallel lines, and this is the exterior outside the two parallel lines. So they are interior, and co means on the same side. So 4 and 5 are on the same side of the green transversal. 3 and 6 are on the same side of the green transversal. And they are, Ashi, they are equal or supplementary?
So they're supplementary.
Supplementary. And you can clearly see, if in doubt, you can see that one of them looks acute, one of them looks obtuse. So obviously they are supplementary. Okay. And the next would be co-exterior. Okay, Rachit. Oh no, Rachit, you already answered. I'll give it to someone else. Yeah. Snigdha, co-exterior would be?
Co-exterior would be 1 and 8 or 2 and 7. Right?
Yeah, exactly same logic. Co, same side, exterior. They have to be exterior and on the same side of the green transversal. So these are also supplementary. Now, what else is missing? Neve. So we did co-interior, co-exterior. If I just have to change the word co, what will that be? What interior is the next one? Yeah, Akshaj.
Alternate interior.
Alternate interior. Yes, co is the same side. Alternate is the opposite side. Akshaj, can you give an example of alternate interior?
4 and 6. So
4 and 6, right? Both are interior, but on the opposite side of the green transversal. 3 and 5. Yeah, Neeb. If alternate interior, alternate interior is the next. This one. What should the next one be?
Alternate exterior.
Alternate exterior. Okay, tell me which would be alternate exterior.
2 and 8 and 1 and 7.
2 and 8 and 1 and 7. Again, they are supplementary, right? They are equal, right? They're equal. They're equal.
Yeah.
Okay, and then the only other thing would be what? Arnav, do you have any other combination in mind? Your hand is up.
No, sir, I was just.
From before. Okay,
Okay.
all right. The only other thing I would say is linear pair, right? Linear pair, which is effectively on a straight line when you divide into by a line. So that way 1 and 2 are linear pair, 1 and 4 are also linear pair, 2 and 3 are linear pair, and so on. 3 and 4 linear pair. Okay, so now with this understanding, we'll just understand the hierarchy of quadrilaterals. So out here, you have a general quadrilateral. Let me just draw it here. Okay, a quadrilateral is a four-sided polygon, right? So quadrilateral would look something like this. Okay, so everything you can define in terms of your immediate parent. So by that, what I mean is the child of a quadrilateral would be a trapezium. Okay, so trapezium, let's see. Sana, can you define a trapezium? It doesn't have to be textbook definition, but naive word is fine.
One pair of parallel lines.
Yeah. A quadrilateral with one pair of opposite parallel sides, right? One pair of opposite parallel sides. So that's a trapezium. Okay. So what is a parallelogram then? Let's see. Snigdha, what is a parallelogram?
A parallelogram is where opposite sides of a quadrilateral are parallel and equal.
Both pairs of opposite sides are parallel. You mean, right? Yeah.
Yes.
Okay. So is a parallelogram a trapezium then?
Yes.
Correct. A parallelogram is a trapezium. So it's a special trapezium where the other pair also happens to be parallel. So in a trapezium, we said one pair should be parallel. We did not say the other pair should not be parallel, right? If it also happens to be parallel, then it becomes even special, right? That's called parallelogram. So this is quadrilateral, this is trapezium, this is parallelogram. What is an isosceles trapezium? Rachit, what's an isosceles trapezium?
Where only one pair of sides are parallel.
So the trapezium that I've drawn here, then it's an isosceles trapezium.
No, where the non-parallel sides are equal.
Then in the parallelogram also, the non-parallel sides are equal. Oh, what do you mean non-parallel sides? It just so happens that both pairs are equal. Both pairs are parallel. And while defining a trapezium, I just said one pair of opposite sides should be parallel. If you say the non-parallel opposite sides, that means you're forcing that the other pair should be non-parallel. Are you with me? Sorry, Rachit, did I confuse you more? Okay, so can you define an isosceles trapezium again once more, Rachit? Maybe I didn't fully catch you.
Please, I don't understand that.
Okay, I'll pass it on to Ashi. You want to take a chance? You want to take a try? How to define an isosceles trapezium?
Isosceles trapezium will be a trapezium. So again, it will have two parallel sides.
Yeah, so you don't even have to say because you're saying it's a trapezium, which means is that all the traits of a trapezium are already there. You only have to qualify what extra.
So what happens? The line of symmetry will be. 1 second, so let me frame myself. No, sir, I'm not so sure.
Okay, Arnav, yeah.
Sir, an isosceles trapezium is a trapezium in which the base angles are equal.
Excellent. Yes. So the base angles are equal. So if I form a trapezium, something like this, right? These base angles are equal in isosceles trapezium. I call it IT. So it's a trapezium where the base angles are equal.
I have a
Okay.
question.
Yes, Sana.
So does that mean a rectangle is also a special trapezium?
Very good. And can you extend? In fact, that was going to be my next question. What else can you say?
You can also say it's an isosceles trapezium because the base angles are both 90 degrees.
And what else can you say? It's also a parallelogram.
Yeah.
You said it's also a trapezium. So a rectangle is a child of both a parallelogram and an isosceles trapezium, because first of all, I'm not even going to talk about trapezium because trapezium is the rectangle's grandfather. I'm only talking about the immediate parent. A rectangle is a parallelogram because both pairs of opposite sides are parallel, and therefore it's definitely a special parallelogram. And like you rightly said, the base angles are also equal, and therefore it's also an isosceles trapezium. So a rectangle have a very short definition. So always when you have to define something, just rely on your immediate parent to make a short definition. A rectangle is a parallelogram that's also an isosceles trapezium. That's it. You don't have to start with a trapezium. You don't have to start with a four-sided polygon or a quadrilateral. None of that. A rectangle is a parallelogram that's also an isosceles trapezium, right? So rectangle derives both traits. Okay. Now, what do you think is the other child of a parallelogram? Snigdha. Signa just answered. Like, I'll just give it to someone else. Saurabh. Okay, so rectangle derives from a parallelogram. There's another shape which also is a special parallelogram. What's that?
So a square.
Square, but square is super special. Even before reaching square, you have something else. Akshaj.
So rhombus. Yeah.
Rhombus. Excellent. Yes, rhombus. So rhombus is a special parallelogram, right? So it's a special parallelogram. So what is the speciality, Saurabh? The special parallelogram where?
So it's a special parallelogram. So I'm not sure why, but I know it.
Okay, Akshaj, can you complete? It's a parallelogram which also has what? In addition to a general parallelogram which may not.
So also all sides are equal.
Exactly, right? That's where the specialty comes, right? In a general parallelogram, it need not be that all sides are equal, but in a rhombus is a special parallelogram where all the sides happen to be equal length. Okay, just like a rectangle, all the angles are equal. The rhombus, all the sides are equal. Okay, so which is why you remember, I think I talked about it in the first class. Arnab, you had a point to make, or what is that? Your hand is
Okay,
raised.
I wanted to answer the rhombus.
This only. Okay, so a rhombus is equilateral quadrilateral, and a rectangle is an equiangular quadrilateral. As in, all angles are equal in a rectangle. 90, 90, 90, 90. The total has to be 360. And all the sides are equal in a rhombus. So equilateral versus equiangular. So this is equilateral quadrilateral, and this is an equiangular quadrilateral. Okay, and as you guys all said, right, a square is something that's both a rhombus and a rectangle. So anything that's below is everything that's above. So is a square an isosceles trapezium? Yes. Right? Is a square a trapezium? Yes. Is a square a quadrilateral? Yes. Is a rectangle a quadrilateral? Yes. Right? Is a trapezium a rhombus? No. Right? If you're going down, not necessarily, right? So it may be, may not be. But if you're going up, it definitely is. So square is definitely all of the above. So this is what rhombus, and this is rectangle. Okay. Now we are missing one other object here in this entire family history, right? Family tree, sorry, not history. What does that shape be? Akshaj. Any other shape is missing?
No, I don't think.
Anyone? Any shape that's missing? Open it up for everyone. Anyone?
Kite.
Kite, exactly. And where would a kite fall in this picture, Sana?
It doesn't have any parallel sides.
Yes. Therefore, it is not a derivative of parallelogram. That's
Yeah.
for that's sure. Yes.
Um,
So sorry. What did he say? It need not have parallel sides. That's how it should say, right?
It need not have parallel sides. So it doesn't even fall under the trapezium.
Yeah.
Um,
Excellent.
yeah, but it has two sides which have the same angle.
Yeah. It has two pairs of consecutive, so two pairs
Two
of
pairs.
adjacent sides which are equal,
Yeah.
right? So in a way, it's a parent of rhombus. So it's something somewhere like this. So in fact, I should put it along the lines of a trapezium because it takes the same precedence as a trapezium. I should, if I go for the straight lines like this, it's a problem. Okay, so this is equal to this. This is equal to this. Okay, and therefore it has two pairs of adjacent sides which are equal, and therefore it is in a way a parent of rhombus. So rhombus is both a parallelogram as well as a kite, right? Because rhombus, all four happen to be equal. A kite requires only two pairs of adjacent sides to be equal to each other, right? They need, sorry, two pairs of adjacent sides which are equal, but they don't need to be equal to each other, right? In a general kite. Whereas in rhombus, it's a special kite where that happens. Okay, is Ashi, is your brother disturbing you? Ashi, your brother wants to be in the class, is disturbing you? No, it's fine. I'm just kidding. Okay, doesn't make sense, guys. Okay, so yeah, so let's talk about all of these in terms of three things. One in terms of sides, one in terms of angles, and let's also talk in terms of diagonals. All of these. Okay, let's start from the top. Okay, so trapezium. Is there anything you can tell about sides? No, other than the one pair of opposite sides which is parallel. Nothing else you can say. Angles also you cannot say anything. They can be general. As far as an isosceles trapezium is concerned, in fact, I'll let you guys answer this, right? So Akshaj, any comments on sides, angles, or diagonals of an isosceles trapezium?
Of an isosceles trapezium. Two angles are equal.
Yeah, so the base angles are equal. So in fact, two pairs of angles are equal.
And
This is
there
equal to
are
this.
Two diagonals.
Sorry, say that again.
They will have only two diagonals.
Any quadrilateral has only two diagonals. You should tell them something which is scarce, right?
Yeah.
Something that's special.
The sides, they are parallel.
Yeah, that's because it's trapezium. Anything else?
And they're equal because it's isosceles.
And the base legs are also equal, right? This pair of sides are equal, right? Just like the base angles are equal, the base sides are equal. Jan, anything else in an isosceles trapezium?
The two diagonals are equal.
Excellent. The two diagonals are equal in an isosceles trapezium. So I'm not writing it because it will get too cluttery here. So okay, in fact, I'll just say diagonals are equal. Diagonals are equal. And then we talked about the sides, right? The base legs. Base legs are equal. The base angles are equal. Base angles are also equal. Okay, I'll just use a sharper pen here. Okay, so that's isosceles trapezium. Let's move on to Rachit. Now we are talking about parallelogram. Comment on sides, angles, and diagonals.
In a parallelogram, both sets of sides are parallel to each other.
That's a definition, and they are equal as well.
Yeah, and opposite angles are equal.
Opposite angles are equal.
And
adjacent angles are supplementary, right?
Yeah.
So because that's the parallel lines. So if you look at them as parallel lines, the adjacent angles would be what angles, Rachit? Like, for example, alternate interior, vertically opposite, like that. These
co-interior.
Co-interiors, yes, exactly. So co-interior angles are supplementary. So these are supplementary. Okay. So anything with the diagonals?
No, sir. They intersect in 90 degrees.
Okay, Saurabh, do you agree or disagree with him? He says in a parallelogram, the diagonals intersect at 90. Do you agree or
Uh,
disagree?
Yes, I agree.
You agree. Okay. No, they don't intersect at 90. And if you draw a parallelogram, something like this, right, which is almost looking like a square or something, then you might be tempted to think that they are intersecting at 90, like this and like this, right? So it's misleading, right? Always, when you draw a diagram, draw it very, very skewed. So I will draw a parallelogram where this side is very skewed, and I'll make sure this is very long compared to this. So if I do this, then it'll become very obvious that the diagonals are not, right? This is one diagonal here. Okay, sorry. You can see, right? The diagonal is here. I don't have control of this mouse. It's a bit of a pain here now. Okay, so this is one diagonal. And let's say this is the other diagonal. You can clearly see the diagonals are not intersecting at 90, right, Rachit? Right? So they're not intersecting at 90, and it becomes very clear when you draw a very skewed parallelogram, whereas here it's tempting to think it's 90, the diagram below. Okay, but anything else in terms of diagonals, guys? Saurabh, there is a property of diagonals in a parallelogram. They are not at 90-degree intersection. Are they equal in length, Saurabh? Diagonals in a parallelogram? Draw it and see it for yourself.
So they should.
Sorry, say that again. They should what?
They should be, yeah.
They should be equal. Clearly not, right? One diagonal is long, one diagonal is short. You can see that, right? But there's still one more property. Give it a Snigdha. Snigdha, anything about diagonals in a parallelogram?
I think they bisect each other.
Excellent. Diagonals bisect each other. So the word each other is important. Diagonals bisect each other. Okay. So what's the difference between intersect and bisect, Arnav? What is intersect? What is bisect?
Sir, I've never heard of the word intersect.
Come on. Intersect and bisect, you would have heard of this. I'm sure you're lying, right? So these two lines are intersecting, right? Bisecting is what? Arnav, take a guess. What does bisect mean? Take a guess.
Sorry, sir?
Take a guess. What does bisect mean?
So bisect, I know what it means. So
What is it?
Means divide in half.
Divide into two. Exactly. So intersect is just random intersection. Sorry, intersect is just random intersection. Bisect is dividing into two. And then she used the word very carefully, bisect each other. So one diagonal bisects the other diagonal also bisects this, right? For example, if I have two lines here randomly, there's a green line and there's a blue line, right? The green line is bisecting the blue line, but not the reverse at the top here, right? So the blue line is not bisecting the green. Only the green is bisecting the blue. But in the case of diagonals of a parallelogram, it's both ways, which is why the word each other is important. Diagonals bisect each other. Okay, all right. So diagonals bisect each other in a parallelogram. And then we covered base angles that are co-interior, therefore they are supplementary. Opposite angles are equal, all of that. Okay, let's move on to rhombus. Let's see, Neve, rhombus of sides or angles. You want to highlight?
Yeah, the sides of rhombus are parallel and the opposite angles of it are.
Sides of the rhombus are parallel. It's a redundant statement. It's a parallelogram. So obviously it has to be. You have to tell something that's special.
The opposite angles are equal.
Which also you don't have to tell because it's true even for a parallelogram. So tell something which is not true necessarily of your parent, right? If you say a rhombus has 4 sides, that's even a quadrilateral has 4 sides. What's the big deal? So tell something that's not necessarily true of your own parent, but something special that you carry for a rhombus.
The sides are equal.
Sides are equal. Yes, I'll take that. That's the definition of a rhombus. That in terms of sides. In terms of diagonals, anything? Akshaj, diagonals in a rhombus?
They bisect.
That's true even for a parallelogram. They bisect each other. Yeah, Ashi?
So they bisect at 90 degrees if I'm right.
Excellent. The bisect each other happens even in a parallelogram, but diagonals in a rhombus are at 90 degrees. So diagonals at 90 degrees. Okay, are perpendicular, right? I'm just randomly putting, okay, I'll just say diagonals are perpendicular, fine. Diagonals perpendicular. Okay, are diagonals perpendicular in a kite, Sana?
Yes.
Yes. So diagonals are perpendicular even here. Even in a kite, diagonals are perpendicular. And diagonals are bisecting each other in a parallelogram. A rhombus being both a kite and a parallelogram, the diagonals are bisecting each other as well as they're perpendicular to each other. Okay. And in a kite, one diagonal bisects the other. The other way need not be true. So in this example kite that I've drawn, this diagonal happens to be bisecting this diagonal, but not the reverse, right? So these two are equal, but not the reverse necessarily. But in a rhombus, it'll be, right? Okay. And rectangle, anything, let's see, who are we missing here? Jan, rectangle. Your video is off, Jan. Every now and then you go on video off. I don't want that. Video on throughout the class, please. Are you there? Jan is missing in action. Okay, I'll have to pass it on to, let's see, Saurabh. Rectangle.
Yes.
What's special about rectangle in terms of sides, angles, or diagonals?
So all its sides are equal.
In a rectangle?
So all its angles.
All its angles are equal. Correct. That's how defined a rectangle. Correct. And then what else?
So it has two pairs of parallel lines.
That you don't have to tell because it's a parallelogram. Tell me something which is special, not necessarily true for a parallelogram, but true for a rectangle. Like I keep saying, right? You should tell me some quality which is not necessarily true of its parent.
So the diagonals intersect each other and they bisect each other.
Okay. So first of all, intersect and bisect. If you say intersect each other and bisect each other, if you say bisect each other, automatically they're intersecting. Forget about diagonals. In general, when two lines are bisecting each other, obviously they're intersecting. Only then baat hoti hai ki whether they're bisecting or not bisecting, right? So bisecting each other itself is a qualified statement. You don't have to say intersect each other. Correct?
So I meant like they're perpendicular.
Are they perpendicular? In a rectangle, do you think the diagonals are perpendicular?
For 1 minute, let me draw it.
If in doubt, draw a very wide rectangle and you'll see for yourself they are not, right? If you draw something like that looks like a square, you'll be tempted to think they are. But if you draw a diagonal something like this, you can clearly see that one angle is up. Yeah, one is obtuse, one is acute, right?
Yeah.
So clearly they're not intersecting at 90 degrees. Anything else? You're missing a very, very obvious point. Neve. Anything to do with the diagonals in a rectangle?
So they're the equal length.
Exactly. A rectangle is both a parallelogram and an isosceles trapezium, right? And because it's derived from an isosceles trapezium, the diagonals are equal in length. So that quality you can highlight, which is not true in a parallelogram, right? So it brings the quality of a parallelogram in that the diagonals are bisecting each other. It brings the quality of an isosceles trapezium in that the diagonals are equal to each other. And therefore, it's both bisecting each other and equal in length. Okay. Let me ask you one other question. Okay, fine. Let me just think about it. Okay, all right. I'll keep it for the end. Okay, so square obviously is everything, right? So diagonals are equal, perpendicular, right? Bisecting each other, all of those qualities. So it's both a rhombus and a rectangle. Therefore, it'll have all these properties. Okay, so the question I wanted to ask is, in an isosceles trapezium, can the diagonals be perpendicular? Is the question. In an isosceles trapezium, can the diagonals be perpendicular?
Yes.
Okay. Can you expand on that, Sana? When does that happen?
When it's a square.
Excellent. Okay. So a square is an isosceles trapezium where the diagonals are perpendicular. But follow-up question. In an isosceles trapezium, if the diagonals are perpendicular, is it necessary that it has to be a square? Okay, understand my question. I'll repeat my question again for everyone. She answered the first part right. In an isosceles trapezium, can the diagonals be perpendicular? She said yes. Immediate answer, yes, because all I need to give is one example where it's possible. A square is an isosceles trapezium. And it's in a square, I have the diagonals which are perpendicular. Therefore, the immediate answer is yes. Now, the other follow-up question I had was, in an isosceles trapezium, if the diagonals are perpendicular, does it necessarily have to be a square, or can it also not be a square?
Sir, it has to be a square.
Okay, Jan says it has to be a square. What about others? Do you agree or disagree? Snigdha, do you agree or disagree with him?
I'm not sure.
Okay, can you guys think?
Can you
Yeah,
repeat the question?
Okay, actually, I won't repeat the question. Someone else will repeat the question. That would be Arnav. No, Arnav already had a chance to repeat one question. Jan, repeat the question for Saurabh.
So sir asked that in an isosceles trapezium, could the diagonals be perpendicular? So the answer was yes, because in a square is an isosceles trapezium. The
Very good.
diagonals are perpendicular.
Very good.
But then the follow-up question was, does it necessarily have to be a square, or just in a normal isosceles trapezium, the diagonals could be?
Excellent. Very well repeated, Gyan. Yes, very well repeated. Yes. So in an isosceles trapezium, can the diagonals be perpendicular without it being a square? That's the question. Yeah, Sana, your hand was up in between.
Yeah, I wanted to agree.
That it has to be a square.
Should I give an explanation?
Go ahead, please. Yes.
So, and the quality of an isosceles trapezium is that the base angles are equal.
Correct.
But when the trapezium is split into two qualities for the isosceles triangle as well as the parallelogram, you can see that in a parallelogram and a rhombus, the base angles, one is larger than the other. So, which helped create the quality that the diagonals are perpendicular.
Please repeat the last part again once more.
So because the angles are different in like one is larger and the other is an acute angle, it causes the property of the diagonals to be perpendicular to happen, and it's only in the instance of a square where it's 90 degrees in which the diagonals are.
So I think it can be perpendicular, but it won't bisect like in a square.
Okay. I never talked about they having to bisect each other. So you're saying it is possible for it to be not a square?
I think so.
Okay, go ahead, explain your answer, Snigdha, a little bit more.
I'm not sure quite how to explain.
That's fine. Your intuition is right. It need not be a square. So here's
why. Because like diagrammatically, when you think of it, then if you just take a square, draw the diagonals.
Yeah.
And then you extend them in one of the directions.
Excellent, excellent. Yes, exactly. That's exactly what I was coming to, right? So let's say this is the intersection point that you're talking about. So Sana, so let me just draw two perpendicular lines, a perpendicular like this and like this, right? And then what she's saying, I'll extend both, right? But I'll extend it larger than how much a square goes. I'll extend it even larger than how much a square goes. Now I can complete this picture and say it's an isosceles trapezium. Does it make sense, guys? So it's very much an isosceles trapezium. Very well answered there, Snigdha. Okay, does it make sense? Sana, do you understand your flaw in your explanation?
Yeah.
Okay. All right, cool. So we understand all of this, right? The quadrilateral hierarchy, like from this point onwards, you should be able to answer any twisted question. You should be able to be very clear however way the question is posed. Okay, so one last thing I would say is a cyclic quadrilateral. before we wind up today's class. Cyclic quadrilateral. Quadrilateral. Does anyone know what a cyclic quadrilateral is? Rachit, do you know? Have you heard of this? Anyone? Okay. All right. A cyclic quadrilateral is, Akshaj, yeah.
It will be where the angles which are opposite to each other of the quadrilateral, when you add them, they equal to 180.
Exactly. Right. A cyclic quadrilateral actually is nothing but a quadrilateral which is encompassed within a circle. So a quadrilateral, something like this, right? I'll just draw a general quadrilateral so that you don't make any wrong assumptions. So this is a cyclic quadrilateral. Okay. And a property of the cyclic quadrilateral is opposite angles add up to 180. So this angle and this angle will add up to 180. So let's say I'll just give an example. Let's say this is this looks like what, 80 degrees. Then this will be 100 degrees. Okay. And let's say this is 130 degrees, and let's say this is 50 degrees. So all the four angles will add up to 360. That's true for any quadrilateral. But in a cyclic quadrilateral, opposite angles add up to 180. So this is a cyclic quadrilateral. You can encompass a cyclic quadrilateral within a circle. And further, there's another important property, right? Which is true of a circle. Let's stop here. I want to do circles properly. So it's not I don't want to do it right now. Okay, so cyclic quadrilateral you understood, right? Okay, so let's continue next class. I want to do a bit more geometry, then we'll switch gears to permutation, combination, or some bit of algebra. Okay, but a good class today. I got very good response from everyone. All of you thought through, listen to each other's questions, arguments. This is what I'm going to do. I won't repeat any question. If there's someone didn't understand a question, I'll make one of you repeat the question, right? So be attentive, guys. Okay, see you next week.
Thank you, sir.
Yeah, bye.